I'm Pfrang. I'm Professor of Atmospheric Science at the University of Birmingham. I have a broad interest of research. More recently, I've moved into trying to understand indoor air quality, which is a very important topic. It has only been recently recognized as a major challenge, largely caused by the COVID lockdowns, realizing that we spend so much time indoors, 80 to 90% on average for a UK population. And I think it's really amazing how little we know about the indoor air. How little we know about what I'm breathing right now, because in many locations, first of all, there are no measurements, there is no understanding how air moves in indoor spaces, and also there's very little regulations, especially in private homes.
We have become much better at insulating our environments, and this is a very nice thing, but by insulating the indoor environment from the outdoor, and kind of short-circuiting this connection, what we might be doing as well is keeping some pollutants that we produce indoors in the environment and not exchanging sufficiently. And we might be exposed to those pollutants more than we need to.
If we say that indoor air quality is a major public health concern, our built environments, the way we build, construct and use, that has led to increased concern. For example, we are building now buildings more airtight. So when we are building the building more airtight, it has an impact on ventilation, and that leads to the higher concentration of indoor air pollutants indoors. And then as we spend most of our time indoors, what it means that there is more likelihood that we are exposed to higher concentration of pollutants.
We cannot keep assuming that pollution or bad air quality in indoor environments is something inevitable. So there is an element of health inequality here, and again, the data are very clear on this. It's a stark contrast, even in developed countries like the UK. So that proves that there are material conditions we can act upon, and those have to do with environmental outdoors, of course, having more green areas, being less exposed to heavy traffic and so forth, but also with environment indoors.
This project is called the Indoor Air Quality Emissions and Modeling System, IAQ EMS, which has been funded by the MetOffice and UKRI. And it involves a range of scientists here at the University of Birmingham, but also at Cranfield University and Cardiff.
The Clean Air programme is part of a Strategic Priority Fund programme that the MetOffice have been involved with for the last few years. And it's a very good research program in that it allows us to approach developing solutions for environmental problems in a much more holistic fashion that has been done in the past. It's very important that because a lot of environmental matters are problems are multifaceted, and as a result, if you just home in on one small area of the problem, you tend to end up with unintended consequences. So the idea behind the Clean Air programme is to look really or approach developing the solutions in systems-led and holistic fashion.
So as part of this project, we have three key outputs. So the first output is the indoor emissions inventory, which is work that has been led by Zaheer Nazar at Cranfield University, where we summarize the current state of knowledge for indoor air in the UK specifically, identifying what are the key emission sources, what are the time profiles of emissions, and what is the kind of complex cocktail of indoor air pollution that we are exposed to.
The work I'm leading entails development of indoor pollutant inventories. As we know that indoor air pollution is a major public health concern, but one of the biggest research gap is at the moment that we don't have a database specifically in the UK looking at what are the different air pollutants of concern. So as a part of this work package, my role was to lead my work along with help of a postdoctoral researcher to develop the first database of indoor air pollutants in the UK. Looking at all the literature that is available for indoor air quality research that has been done in the UK, and then building on that database, then create an easy-to-use tool, and through that tool, then the researchers or the policymakers, then they can visualize and get the information specifically on the air pollutant concentration in different indoor environments, as well as the emission rates depending on the specific sources or occupant activities. So building on that database, then we build up this Excel-based tool. We have also released the first version, and that version is again available through Birmingham University repository. With the tool at the moment, one key vital information that is valuable to the local authorities or the policymakers along with academic researchers is that we can get a better understanding or the quantification about how the indoor air pollutants concentration, they change over time during different activities. And as well, the tool also gives the quantification of emission rates. Now, that is vital in many ways. Let's say, for example, for stakeholders or for general sort of local authorities or other policymakers, it can provide insights into high and low risk environments depending on the level of indoor air pollutants. And then getting that information, then we are able to devise, let's say, actionable interventions at scale. On the other side, for the academics, the tool itself can provide the detailed information about the emission rates for the specific activities. Those emission rates are the numbers, if you want to say, of the different air pollutants for different activities in a specific environments, then help the modelers, numerical modelers, to develop and test their models on indoor air quality.
The indoor emissions inventory also revealed some gaps in knowledge, and that's what we're trying to tackle. Specifically, there's very little study of indoor air quality with reference instruments or high quality instruments that give you a very high time resolution of, let's say you have an emission event, you cook bacon, you have this huge plume of pollution being produced, and that's something that's very rarely measured in the real world. And that's something we're trying to get our handle on, what happens to this pollution. And that's where we kind of link together the modeling tool and the measurement tools. This project has been really an eye-opener for me personally, but also learning more about the remaining challenges in indoor air quality specifically. So we've developed some outputs, but very clearly these outputs show that there are huge knowledge gaps remaining. The emission inventory has shown us that certain locations have been overlooked for measurements. So to get a full picture of what people are exposed to in the UK, we really need to measure in all relevant locations. In terms of the model outputs that we've developed, we have applied them to a very small number of locations. And we really would like these to be used by researchers to apply in different locations. Not a single project can address that. And then the multi-box model, we really would like practitioners to use more frequently. So I'm thinking about architects or city planners and councillors making decisions about, how is the city of the future looking like? Because it's really important to have an understanding of what impact do decisions have on indoor air quality. Because in the end, the exposure of people in new spaces should be minimal in terms of air pollution, and our models can really help to achieve that goal.